Well, hi and welcome to my shop here on September 5th. Yes, it's September, I have to admit to it. September 5th. So, I'm at a really interesting point here with this radio now where something is wrong with it and I don't know what. And that's what makes it kind of interesting. So, I think the approach I want to take, I've been thinking about this yesterday a little bit. I have a couple of approaches here I can take to try to track down where things are going wrong in this radio. And yeah, there could be a number of places where things are going wrong too. I can signal trace, which is to say I can sample the signal as it passes through the radio, right from the antenna, right on through the whole thing. Sample all the way until all of a sudden it disappears, and then I know, oh, well, that must be where the problem is. The signal can't make it past this point. So that's signal tracing. I have a tracer here and can do that. The other way is kind of the opposite. You feed in a signal and start at the speaker and work your way back into the radio, looking for, since you're injecting the signal, looking for the point at which your injected signal no longer comes out of the speaker, and then you've crossed the defect at that point. I think I like that second approach. I think because I'd like to hear some stuff come out of this radio. I think the way I'm going to start is with an audio signal, an audio tone. I'm going to feed it into the phono input. Phono input right here. And we will listen to what comes out. Now that's not starting right at the speaker. That's kind of starting right where the radio changes from a radio to an amplifier, right at the volume control, basically. Volume down. So the signal input is going to come from this signal generator here. I have trouble with this generator sometimes. Sometimes it doesn't want to produce an output, so we're going to have to prove it has an output first before making use of it. And let's start up the radio here. I'm just checking to make sure everything's okay. So good. Keep an eye on those lights. Yeah, there's a light come on down here too. Broadcast band. Yeah, we have to prove that that guy's working. So the way I do this is kind of clumsy. Just take a crappy old speaker here. It's got to be crappy. It's got to be old. What we're going to do is simply power it from the just to make sure there's something coming out of there. Terry Fox. I don't have a lot of real heroes in my life. Terry Fox, my hero. I actually saw Terry Fox for real, running with his small entourage, probably his parents, in a van behind him. You know, if you don't know what I'm talking about, if you're Canadian, you know what I'm talking about. He was running on the Trans-Canada Highway just outside of Sudbury, and my wife and I drove by. We were on our way to a town called Espanola near there, and we saw him. And I've got a photograph, a nice photograph of Terry Fox running at the side of the highway. He is my hero. So if you don't know who Terry Fox is, and most people in the world kind of heard this name, look it up on Google and have a hero. Okay, let's get this thing working now. A little emotional there. There we are. So that's what's coming out. Just make it a little more pleasant tone-wise. Now, the input to a radio like this is really designed for around a volt coming into it from a ceramic cartridge. Oh, this is the right cord. This is the one we want to put on. Volume's down. Signal level, we don't know what it is, but it's something enough to make a little bit of sound come out of that speaker. Okay, should we hear something? We should hear something. Oh, there's a phono. This has to be in the phono switch position. Son of a gun, it is already. Ah! Okay, well, we're off to a big start here. Nothing coming out at all. And I'm feeding a signal into the amplifier portion of the radio. This kind of locates a problem anyway in the audio circuits. So now, with this going, you know what? We can trace now. Hey, we can do both. We can inject and we can trace. We can trace what we inject. Great. Okay. My signal tracer here is a combination of things. It's a radio and it's also an audio amplifier only. It depends upon the switch settings. And just before we do that, while everything's warming up anyway, so there's a mystery wire here. This is the mystery wire. This is hanging out the back of the radio for reasons unknown. And right below it here are the two antenna posts, ground one going to the chassis and the other one going through a small capacitor to a terminal where this wire is connected. So it looks, you know, is this original? I just don't think so. Oh, you know what? This might go to some kind of internal antenna in the radio. So, yeah. So, I don't know. Either somebody did this. It kind of looks like original soldering there. Or this is a wire intended for something, I don't know what. I don't remember seeing anything on the schematic about it. Some of these radios have a thing called a capacitance antenna. I don't know what that is, but I have one right around here. Let me show you. Right around here in my antenna box. Now the reason I have this is, shame on me, I didn't install it in one of the radios I fixed. I went home without this. So this is the capacitance antenna here. The wires kind of come off from a radio very similar to the one I'm working on. This would be like this. And this thing is sitting tucked up on the roof of the radio cabinet, if you like. You can't even see it. This particular one had slots. It slid in and out. And then there's a wire going. The wire. It's still got a connector on it. This heads down to the well, to a wire like the one we're wondering about here. What this actually does for the radio, I don't know. Is this just a, you know, if you don't hook up any antenna, at least you got something going there? So the radio can do something in a store, maybe, because in a store, you know, showroom, they may not have access to a decent outdoor antenna or anything. So I don't know, but often it's called a capacitance antenna. I remember I had a CB antenna, a big 5/8 wave CB antenna. My parents were horrified when I stuck it on our house. I was a teenager. And at the top of it, this long whip antenna, at the top of it were three little pieces sticking out, and that was called the capacitance hat. Related? Now what's making noise here? My signal tracer is making popping sounds. Never heard that before from it. What's happened to you? That's bad news. I don't want my signal tracer to need to be signal traced. Okay, let's get on with it now. So we still have an audio signal. We'll set this to audio. Listen to it. Oh. Sort of de-wire the area here a little bit. Okay. I want this switch to audio. So now it's just an audio amplifier. Whatever it hears on the probe here comes out the speaker. I have a volume control that's controlling sort of the speaker volume. Then I have an input attenuator over here with a step switch and a rotating one. Now you can make somewhat quantitative measurements with this. You can certainly make relative quantitative measurements with it. So I'm going to put the ground on. Always scared, especially a few videos ago. The mystery pop, which is still a bit of a mystery to me. I won't go into it. If you saw it, you know what I'm talking about. Now, I got to move this whole chassis over here to get to my probe to it. And think about that. Okay, moving. Always a bit of a dangerous operation there. So what we're going to do, we're going to start right where the sound's coming in, right on the back here. And hand on the volume control. Well, that sounds pretty bad right there. How can it be that low? I'm basically right on the output of this plug. Okay, well, let's check that out. Volume down, pull this out. Sounds about the same, doesn't it? So I can see my magic eye here is closing right up on this. I just don't have the volume up. That's really the catch. So what we'll do is we're going to set the magic eye to close on this sound. Okay. And so now we can, as we trace through it, we can watch it relative to this. And this volume control is independent of this eye. That's the trick there. Sounds a little distorted to me, but let's go ahead. We know what it sounds like. Okay, now do we get it on the other side? You kidding me? There's nothing there. What am I touching? This didn't even make it through the plug. Huh. This is the shortest signal tracing job I've ever done. I can't get to the other side of the phono plug. There's nothing there. So this big capacitor looks like it's connected there, but it's not. How can you not hear this? I'm going to go right into... What's that funny sound? Something funny coming in my shop here. What is it? Oh. How about an open volume control? Open volume control. Well, I'm not even getting past the plug yet, Jim. Back to the plug. So it's hooked up to this wire here. And that looks like it. Only this wire. And where does it go? It goes... Oops, it goes up and behind into this switch. Have I really got this on phono? There's still no noise coming from this. Okay. So what we want to do, we want to move the input. I really hope this would work. I'm going to move the input of the signal. We're going to have to start with it closer to the output here. It's really close even now. So to do that, I need to change things a little bit here. set things up a little different. So I'm going to stop for a second, get that ready to go. Okay, so all I've simply done here, and I haven't actually done it, is connecting to the chassis here, and then the other output, or the output. I'll come to the end of this pointer, and then I'll be able to poke around in the radio, inject the signal with this. That's the plan. Just before I do that, I realize that we have another opportunity here to do a very simple test. So this is still reacting to audio. There's nothing making it to the speaker. What's making it to the volume control? That's where I was injecting the sound. What is there? Maybe the whole radio is there. I've hooked up an antenna just to give this thing something to chew on. We're going to put this on the volume control slider. And then we're going to turn up the volume and see if we don't hear a radio coming out of my tracer here. Okay, I got to turn up the volume. It's really kind of disappointing. Okay, now there's an input side. This is the input side. This is everything that's coming here. Oh, this is still switched to phono. Hey, good. Okay, so it don't matter where that volume is. Full volume available here. So I'm controlling it with my tracer. My tracer here. So I'm going to turn this down. Move the band switch. We are on this wasn't on phono. Ah, okay. Maybe I blew the last test. So we should be hearing something now coming out of here. Listen to that. And if we tune, okay, so we're really nailing down the problems here now. That's great. It's all in the audio circuits. All in the audio circuits. Okay, so I'll go back to injecting a signal. I'm just using the radio speaker to identify the point where we hit the mark. You know, I need a capacitor in this thing, I think. I might be touching some high voltage. So let's get a little bit of protection in here. This one. What just happened? Did I just hear it? So there's some microphonic component in here. That's all I'm hearing. Okay. Now, the signal level is moderate. The signal will not be controllable by the volume control. So when we get ready for a blast in the ears. But wait, I gotta know what pin to touch here. That's because the schematic I'm using is occluded inside the tubes. We would want to pick either output tube, either a grid of either output tubes. Down here, Jim, get your head where it's supposed to be. 6F6, 6F6. The signal grid is number 5. Pin number 5 is the winner. Okay, don't know what's going to happen exactly when I do this. Pin number 5. So, making sure I don't do this on the rectifier, or that would be too exciting. So I want to count 5 on here. Okay, 1, 2, 3, 4. Okay, I see 5. Now, I gotta try to run the volume here. This is just Let me just turn it down. We'll just do a little tap on thing. Who knows what's going to come. Here we go. Okay, so that sounded just great. Now what about the other output tube? Same pin 5. Same pin 5. Something's probably the tube itself. It's probably microphonic here. Huh, I don't know. Now, if you've been looking at this capacitor and going, oh my gosh, Jim, the capacitor's not connected. No wonder the radio doesn't work. I just can't imagine that this one would silence the radio. Should we touch it? No, we should not touch it. We don't know why this is off. Probably bad solder is probably why it's off. But if it's shorted and I touch it, then well, make for a good video. Number 5, pin number 5. Get to it. Get to it, man. Okay, so it's really tough to get at. I think this is it. Ooh, that's a lot louder, eh? Let's try that again. Sounded nice. And this one. So those are the grids. That's representative of the output of the inverter tube and the output of the detector tube, the triode. Those tubes, if I remember right, God help me, do I remember right? They were of dissimilar strength, and that's probably why we're getting it louder on one side. And I think that's bad news for beautiful sound, but it's okay for okay sound. So now we want to work our way back to the, well, what's this mean? This means, well, it just means the two output tubes are working. So now we want to feed into the grid of the inverter tube and the grid of the detector tube, both of them 6 SQ7s. 6 SQ7s. So if you have a push-pull amplifier and one side is weak, either because the incoming signal is weak or the tube itself is weak, can you hear that? I mean, if it's just a little bit weak. Can you hear that? 6S. Come on, Jim. Think 6 SQ. SQ. You probably can't hear it. You probably have to train your ear to hear stuff like that. 6SQ7 on the grid is in pin 2. Pin 2. But that grid is connected essentially to the volume control. But if I inject in the volume control, we don't hear anything, do we? That's into the volume control. Wait a minute here. Yeah. Oh, we hear something. Not exactly sure why turning the volume down should quiet this. I'm injecting it into the center terminal. Something bad is definitely happening between here, because that should blast out of this radio. If I can get this, then what I did up here should have been much louder yet. That sounded really nice, actually. That particular tube. So signal is going from the volume control to the speaker, but very poorly. We might be at the point now where really we have to do capacitors to go any further. So I think I'm just kind of finding general weakness. I'm not sure I can. If there was absolutely no response from the volume control here, then I might continue to look for a singular defective part. Often my practice anyway in changing capacitors is to do the radio in a couple of sections, the audio section, the IF section, the front end section. So what if we do all the audio capacitors in here? What if I just push this one back there and see the radio come back to life? Wow, wait a minute, yeah, that's not a voltmeter, Jim. get a voltmeter here. So one of the kind of half brainful tests I like to do is to read the voltage across capacitors. I'm sorry, I read the voltage not across capacitors, I'm lying. Either side of the capacitor to, in this case, the chassis. That's what we're going to do. And the normal thing you see is 0 on one side and something on the other. But if you get a capacitor that's got voltage on both sides, it's good to look at that capacitor a little bit more closely. It doesn't mean there's something actually wrong, because that can happen in a radio. But in many cases what that means is the capacitor is leaking. So I'm going to put the meter ground onto the chassis. This is just kind of a fun thing to do because it's so easy. And pick up the correct lead. Yes. We're on DC. DC. This is an auto ranging voltmeter, and I don't like this voltmeter very much. So let's start with B+ and make sure everything's working here in terms of the meter. Just under 180 volts. Low, supplying the radio, not supplying, 96 volts, so it should be working. So this open end of this capacitor, let's just watch carefully what happens here. volts, steady. Okay, I'm just going to go on the other side of the capacitor now and see what the supply side says. It's 160 volts on one side of this capacitor, and on the other open side, this is why I don't like this meter, it beeps at you all the time, 50 volts. So I think a very good capacitor, the moment I touch the lead to the open end of the capacitor, any voltage that would be there would be discharged immediately. You wouldn't even see it on the meter, and the meter would say 0 even though there's a couple hundred volts on the other side. In this case, the capacitor and the meter are forming like a resistor capacitor circuit. The meter is a big resistor, and it's actually able to draw a touch of current. It wouldn't take much to operate this meter right through this. So this capacitor is leaking. Now, did somebody break it free, or did it fall off? I think it fell off. And you know, any surprise in that is leaking? No. Now we'll do the double. I'll just show you what I do here. Again, this test isn't. It's just to identify more things to check more carefully. So we look at this capacitor. We go to this side. We already checked this side. Come on. It's a lot more than that. 160 volts. And on the other side, right here. Ooh, 160 volts on both sides. And there's another one over here. Now that's more like it. This side's probably going to the chassis. Yep. So there can be nothing but 0 volts on this side of this capacitor. So look what's happening here. So we're getting that's the proper 0. Then on the other side is a supply voltage, probably a plate supply of 160. Now, why would they have a capacitor between 2 points and the other point is also 160? Come on, 160. I'll just hold it here till it says 160. There we go. Maybe that makes sense, but I would be pretty suspicious about this. Maybe somebody was zooming in on something here, and this is part of their zooming in. I don't know. Let's just fool around with a few more. Here's a really ugly one here. If one side of the capacitor goes to the chassis, then you're bound to see 0 on it. So we got, this is another mystery thing. When you find a small voltage, what does a radio need 4 volts for? Small voltage might suggest something's going wrong with the capacitor. This is the other side. Oh, that's interesting. So Generally speaking, in a situation like this, you'd expect like 90 volts on one side and 0 on the other. Not 5. So we're just kind of going along here proving these capacitors are really dogs. So this side's going to be 0. And the other side doesn't really matter unless I see a 0. Oh, listen to that. Hey, we found something. This is probably grid on the inverter tube. Was it pin 2? 1, 2. So this is the other similar tube, pin 2. Volume up here. Pin 2, I gotta verify all this. Oh! So there's very subtle noises coming out of this radio at times. And you may or may not be hearing them. Like that. Like that. And just pushing on things. So you could have a resistor here with a broken element inside. Touching it is causing things to happen. Well, you know, this whole area of capacitors has to be changed out. So is that true? Let's see. Now there's the big rectifier tube down here, but the rest of these tubes are all involved with audio. We've got them all crammed together here for good reasons. Looks like 1, 2, 3, 4, 5, 6, 7 capacitors. They could throw in maybe even these ones. It's a weird assortment of capacitors in here. 7 capacitors. Which one's most likely to be the killer? Hey, let's look at the schematic a little bit. Okay, we're fooling around in the audio area. That's in here. Yeah, well, we look at the signal path. Let's take it out of here. This capacitor could be a problem. And what is that? 0.00 something. 800 volts? 500 volts? Why so big? Really, it could be in one of these. Is really kind of the easy answer to this. I should just change them all, and there's a few it's not likely to be. It's much more likely to be like, I think this is conveying a signal. This is the B plus coming up through here, I think. Yeah, any one of these. And you know, maybe they're all kind of weak and tired, and together they can't hold the row anymore. Okay, back to the radio here. Turn the power off before I forget. The radio's on. Well, I mean, there's no question. This little thing here is this is some additional. This is unexplainable. This is also unexplainable. Wow, it's just floating out here. The piece of wire sticking out. This would not be done in a professional setting. Like, it almost looks like this wire and this wire used to go straight to this control, and these have been added in. Let's look and see if this appears on the schematic, or this for that matter. This wire heads for a oh wow, it's easy to get tricked. It goes way over in here and disappears. Yeah, it heads up kind of into the audio, into the output tube, and detector heads up in that area. Does it make sense? Yes, it makes sense. We'll go back to the detector. No. This isn't volume. This is tone. Okay, hold on. Let's quickly. This should add nicely to the confusion. So if we look at the tone control here, this one being the one we're concerned about, yeah, would be this tone control does not appear to be wired at all the way it's shown here. Just whatever it is I'm looking at, is it this? Well, this is the other tone control. Yeah, this thing's been fiddling around with. This is not the way it's done. This is not done like this. This has been fooled with. And so so here's the control, and off the one end you encounter immediately two capacitors. So if I look at one end and the shielded wire, there's a shielded wire coming there. Where? No, that shielded wire. There's no shielded wire. What has been done here? Oh my gosh. Time for a split screen, I think. Okay, let's see if we can sort this out. It might be very hard to see in the camera. Let's just carry on. So, what was I talking about? I was talking about... Let's start with the volume control. The volume control has a shielded wire coming off the back of it. I'm just going to look myself and... what? Well, I don't see any shielded wire. Yeah, here it is. So this shielded wire, can you see what I'm touching here? I got a little bit of problem with seeing my own computer screen. Yeah, you can just see my finger there. So that's going out to the volume control, shielded cable, snaking its way up to the detector tube. That makes sense. Now, where's this one coming from? I mean, it's soldered right here, so you'd have to think it's aimed to come to this control, but you can see it's kind of like swung out and this capacitor is stuck in there. Yet there are supposed to be capacitors, but they would probably be at the other end of this wire. Somebody looked at the schematic and misinterpreted it and decided they had to put capacitors in where they weren't. See, there's excess wire here. This wire will go all the way to this terminal. This is just a tone control. You can't really be shorted because you can open it up here. So how can this cause the radio to be dead? I don't think it can, but it certainly raises questions about what is going on. What has gone on with this radio? This wire doesn't look quite right either. Just the way it's coming through here gives me the feeling. Now the other side goes right to ground, and we look up at the schematic here on the yeah. So if we look here, what we really should see. No, this is not wired. Neither of these are wired the way it's shown on the schematic. I'm pretty sure it's bass and treble. Yeah, my cabinet's out in the garage. I don't want to run out there and look. I just can't see that either of these would cause the radio to go dead, but there's certainly questions about what's going on here. Oh man. Well, I'm going to pick a couple of these capacitors, change them, and test the radio again, and we're just going to work our way through and just see what happens as I go. Maybe this will come clearer. Often things become more clear as you progress with this stuff. And just as I predicted, as soon as I started, right away I saw something. So this wire from the treble control gets through the radio and is attached to this terminal right here. And this terminal is then connected to this capacitor, which is then connected to the terminal on the detector tube. Pin number 6. Pin number 6. So it's capacitor to pin number 6. And the schematic, I don't think it shows pin numbers either. Yeah, really, schematic's not helpful at all because no pin numbers, and the tube is occluded on the diagram. So okay. Just want to make sure. I just don't like to leave too many open. You know, that's probably this, and this is probably that. And you get too many probablys in a row, the probably goes down a lot. Can't have too many probablys. So again, it was pin number. 1, 2, 3, 4. Definitely pin number 5 has this capacitor on it. Pin number 5 of the 6SQ7. It's one of the diodes. One of the diodes. Okay, let's look at the schematic because I can't make sense of that. So I think I've just traced this wire, and it appears to be connected to, well, yeah, one of the diodes. That doesn't make any sense at all. This wire and this wire should be connected to the diodes. This wire should be coming from the plate. You can almost see it. That's got to be the plate, and you can pretty much see it straight up. And it's definitely the plate wire here. And then this is not done this way. The way it's done is it's a series resistance. It's a varying series resistance. So it would be as if this wire's not here, as if this piece is not here. And that might amount to kind of the same thing. I'm not sure. Likewise, this one is not done like this. It's just, oh boy. And the size of this thing, I have trouble understanding the size of these parts. So that's not making sense at all. So what did I do wrong? What did I do wrong? Let's just go back a bit. 6SQ7. Yes, 6SQ7. 5 is one of the two diodes. Pin number 7. This is a rectifier out detector, pin 7. Or is this the inverter? And this guy's the detector. One, 2, 3, 4. That's pin 5 without a doubt. Okay, so I don't want to burn my brain up too much here. And then this is a fairly large capacitor. Now what if we try to trace these guys down? These two. So they're both connected to the same pin on one of the output tubes. In fact, this appears to be between the same two pins. Could be the one that's on across the output transformer. So what pin is that? That's pin number 1, 2, 3. This pin 3 here, be pin 3 there too. Pin 3 on 6F6. Pin 3 is the plate. So that would look like a capacitor between plates, and that would explain why I had the same voltage on either side. And then we had plate to ground was fine. So I think these are probably okay. I mean, these are pretty new and they look good. These are probably not a problem. Not when you got stuff like this sitting here. I also have this one, molded one. These are known for being bad actors. So let's figure out what this one's doing. So it's coming right from a pin all by its lonesome, which is perfect. And this is on the inverter. And the pin would be 1, 2. Pin 2, 2, 2, 2, 2. 2, 2, 2. Pin 2. Pin 2 on the inverter. Pin 2 is the grid. Well, unless I'm mistaken, the grid gets the same signal as the other two. That can't quite be. Somehow there's an inversion that takes place. So we look at the schematic and sort that out. Pin 2, let's check this. Oh, the schematic's right there. Come on. So on the inverter, pin 2 is the grid. Which one's the grid? Pick a grid. Anybody got a grid here? So it must be related to the, no, this is going to ground. Why is it sneaking the signal down there somehow? Well, they're taking the signal off. Oh, so that's what they're doing. I think they're taking it off of the plate circuit, and then how's it getting? And then they're sticking it in the grid here. What's this? Is that a feedback line? This might be feedback right through here. Feedback is a technique for reducing distortion. It costs you a little bit in the output, but make a great improvement to distortion. But push-pull is inherently low distortion. Am I getting anywhere at all here? So going back here, so output from here, this is how you get the inversion, because the tube inverts the signal. So if you take the inverted signal and then feed it in the grid here, you're going to get an output from this tube that will be inverted from this one. So that's why they're utilizing the output here. Then they have to pad it, control it, and get it established properly. So coming back from grid pin 5, we should meet up with a resistor. Well, we meet up with this capacitor, and meet up with a resistor, and a resistor should meet another resistor. Okay, look in the radio. We're coming from 5, we're meeting a capacitor. There should be a resistor. Boy, this is, what? So if you come away from pin 5 on the 6SQ7, you should meet up with a big resistor. Well, it looks big on the schematic, and a capacitor, but there's only one thing soldered there. Did somebody just mess this radio right up royally? Did I work on this radio once? Is it me? Is it me? Oh my gosh. You know, there's a couple of approaches here. Well, one is you just change the capacitors where they are with the size they are. That's the shotgun technique. Don't bother with the schematic, don't bother with anything. You gotta cross your fingers at the end of that. Having found some weird stuff in here now that I believe is weird, like this, and that, very hesitant to do that on the basis that somebody was trying something here. Somebody somebody was trying something. Now, if you do go back 30 years, this radio could have gone into a shop, and the guy working on it may have never had a schematic for it. It's possible. And he just used his knowledge to do his thing. And that's why we got what we got now. No schematic to check back. Who knows what the history is on these things? Who knows? Who knows what evil lurks in the hearts of these old radios? So I think my approach is going to be leave these two, get rid of this, this, and this. Operate the radio. We'll do these three. Maybe this one too. 4. We'll do 4. This one doesn't count. It's out for 1, 2, 3. We'll do 4. We'll leave this thing hanging for now. Well, I would have to identify this. Why don't we identify this? Then I can go ahead and change it. So, well, it's on the plate. It's on the plate here because this is on the plate. So it's a plate. There should be, if they're doing it here, they should be doing it over here, shouldn't they? And they do the same thing on both sides. Doesn't appear that way. So, but this is I don't know. Let's take a look and see. Let's see if we can find this. It's pin number 1, 2. Well, 3. Plate. It's the plate. The plate. Oh yeah, and the schematic's right there. Yeah, great. Okay, on the plate of one of the two output tubes, pin 3. Oh yeah, pin 3 on the. Well, it's on the plate. It's going to ground on the plate, straight to ground, right off the plate. That? No. This is grounding the metal can of the tube. This is that. Yes, there's one on every one of these. So this is probably related to the cathode more than anything right here. Plate. Capacitor going straight to ground. There it is, way down here. Wait a minute. No, that's through a resistor. That can't. Oh my God, have I got the wrong schematic? No, this is absolutely the right. 981X, it's absolutely the right. You know, I know I'm getting desperate when I start all this. I just really worried about working on this radio and perpetuating errors that are in it, and 2, making my own additional errors, and then C, if I go ahead and try to restore this back to the way it is on the schematic, that's a huge mistake too, because of reasons I don't know yet. I mean, it got this way somehow, and I don't even know for sure that this way is a bad way. But I also don't know what else to do, so I got to do something. So I'll do the plan. I will change those capacitors. We'll shotgun 4 of them. Maybe not. We'll work on that stuff. Okay, I think I figured one of these out anyway. This big guy is on the screen circuit, and for the output tubes, and its job obviously is to try to quiet the screen circuit so there's no signal left on it. So that's really important. Would it kill the radio if it was open? I don't think so. Shorted? Maybe? I'm not sure. I doubt it's shorted. So I know what that guy is. Hey! I know what this guy is. And I know what this guy sorta is. I know what those guys are doing, kind of. This one here, I still don't know. What is he up to? He's going from a pin on the inverter tube to one of the output tubes. Here, so it's going from pin 5 of an output tube. Pin 5 is a grid. Pin 5 of the output tube, and this is probably plate here of the inverter. So this is pin 876, pin 6. I think that is the plate of the inverter. 6SQ. Why don't I put bookmarks in here? They said pin 6 is the plate. So I'm pretty sure this is just basically feeding the output from this inverter over. So a weak here, a weak capacitor here, leaky B plus problems for sure. I think I got kind of an idea what all these are doing now. So I'm a little more comfortable going in and changing them. Okay, well, let's start with the big one. Why not? Starting with the big one's actually kind of a good idea in a way because its replacement's going to be a lot smaller. This is a 0.1. We're going to put this on the capacitor checker. Looks nice. It's a nice looking capacitor we have here. It was 9 degrees outside this morning when I first got up. 9 degrees, man. Fall comes suddenly. Okay, so we're going to put 50 volts across this capacitor. We should watch the eye. If the capacitor is good, the eye will end up the way you see it now, open. I don't think it's going to open. So that indicates this is a leaky capacitor, this big one, and this is a leaky capacitor on the screen circuit. The screen circuit is got a fair bit of current flowing in it. A tiny little leak in here probably wouldn't affect it, but we don't know what quality the actual capacitance of this is anymore. I can't measure it when it's leaky like that. Okay, so that'll be the first one I'll put in. Great. One of the mistakes you can make in these old radios is trying to solder right to the chassis. You need a big honking soldering iron because the heat is just, even I'm having trouble even with this, what I'm doing. The heat is drawn away so rapidly. So I leave a tail on here from the old connection. The old connection wasn't exactly great either. But a little soldering iron like this really doesn't have the heat to heat up a big chunk of chassis like this. I'm just trying to get the lead wire to, there it goes. There. Could have done a little farther out on the original lead wire. Go down here. Okay, and I've already partially cut away the next capacitor, which is this one. Just going to this terminal. Going to this terminal. Cut them right off. And use an ugly one. 0.007. 0.007, eh? Wax all over the wire. Okay, same test. 50 volts, watching the eye. Let the truth be told. It's going to open. But I think it's leaking terribly. It's just opened a little bit. This is just 50 volts. And if you can see it, it says 25 here. Don't believe it, it's 50. 0.007. 0.007. You know, that's just such an odd size. 0.007. It's 0.07. So what am I going to do? I don't carry a 0.007. So I've got everything but 4, 6, and 8. There may be a 7 in here. What's that? 0.007, isn't it? Well, that says 0.007. I'm convinced. We got the capacitor we need here. Okay, so I'm going to try to remember where that came from and then stick it in the right spot. So it's where it's supposed to be. It was from here to this terminal. That's a long journey. Okay, get that guy in. Two. Why wouldn't I just go ahead and change this and do it, to put it back where it should be? Look at that thing. I'm supposed to read the value on it. There it is there. 0.005. What's it? Another size I don't have. And they kept the even sizes. Where do you get a 0.005? Now you can get it out of this tray. Zero 0.047, 0.005. Now, where did I get that other capacitor from? Oh no! Oh, this happens all the time. So this was really tight up against here. I don't remember exactly. Oh, this was the one that was hanging out. Right. Thank God. Okay, so it was like this. Right on. It's a pretty busy terminal there. That capacitor in with virtually no, of course it's a bigger capacitor. I was going to say with virtually no lead length at this end. That could be a reason for that. Best arrangement, but I didn't test that capacitor, did I? It was like a blow on it. What I figure I'm doing there with that short little puff of breath is I'm blowing the temperature down from some very high temperature to a high temperature. I'm trying to get it away, get the high temperature out of there. That's what I think I'm doing. What I'm really doing is probably nothing. Okay, let's get this extra piece of wire out of here. Almost invisible. That's 3 capacitors done. Should we test the set at this point? You know, the smart money is yes, you should test it. Okay, let's go for the smart money. Volume is down. Tone is, who knows what's going on with the tone. Switch is on broadcast band. Dim lights in. Everything looks normal. Normal activity. Volume up. I don't expect this is going to make any difference. Let's see. Give it a fair length of time to warm up because it's on restricted voltage, 98 volts. 97.9 volts. Volume's up full. Band switch. No sound. So we know we can be darn sure that when I flip that band switch, darn sure by the way, when I flip that band switch, it's issuing some noisy sounds out of the radio part of the radio into the audio part. We should hear it. We don't hear anything, so that tells me this hasn't made much difference yet. No surprise. I think the problems are, I think there's a hidden problem in here. Hidden from me. Okay, I'm not sure, that might be the end of the video here today, so I'm going to say goodbye at this point, and we'll carry on tomorrow, or nix that. I'm doing these next 2 capacitors here. Let me get those done. Yeah, I got time. I got time. Okay, so I'm going after this guy here. Got him there, got him here. Now, something I can do to help me remember where these come from. You simply clip a lead onto the spots. There. Ah, now I'm safe. Okay, over to the capacitor checker. I think this style of capacitors are really bad. How bad is it? 50 volts. Oh, popped open, but only part way. So it's indicating that it's a leaker. So I've never, you can. Have you noticed I'm not testing the actual capacitance of these capacitors? No use. Once they're leaky. Now these kind of capacitors sometimes just have a serial type number on them. .400 volts, so I think that's the rating right there. Magnifying glass here. Ah, well, here it is. Very good. Let's see what this really says. Well, I think it's a .01. Wow. rub the dirt off without rubbing the words off. .010. I put an extra 0 on it there. Yeah, 0.01. Okay. 0.01. Got a few of those. 0.01. I got all kinds of them in here. So this guy. I don't know if I need to use a high voltage one. That's a 100 volter. Great big one. This is 0.001 in the wrong bucket. No, 0.01. It's 0.0095. Wow, that's precision. 1200 volts DC. That's why it's so big. It's a little bit of overkill. These blue ones are all 100 volt guys. So without having to figure out what the real voltage is, I'm going to put in this higher voltage one here. 0.01. 600 volt capacitor. Go. So right after the Second World War in Canada, like a lot of countries, there was a huge amount of war industry that came to a dead stop at the end of the war. You had factories, people, nothing to do anymore because there's no more orders for war materials. So what the governments did was they set things up to, I guess, utilize the factory settings that existed and start making stuff. And in Canada here, quite a bit of British radio technology came this way and got set up to build radios here in Canada. Not for export back to Britain, I don't think. I think it was all just for the Canadian market and to employ Canadians, Canadian soldiers. I think. I want to put a little piece of protective hose on there. How about some nice blue color. Got way too much wire here. So some of the radios I've worked on, ooh, there it is, were built in those factories. The war, you know, I used to live in a city called Pickering. It's about an hour and a half from here to drive. It's right down on Lake Ontario. I lived right near the Pickering nuclear power generating station. So if you look up Google Maps and look at the Pickering nuclear plant, you see a picture of it, and you're looking, my house is probably in that picture, like an aerial view of the nuclear plant. And I've forgotten exactly why I was even saying that. Why was I even saying that? Right, because Pickering is next to Ajax. Ajax is another town. Come on. Ajax is where much of the Canadian war, like weapon, ammunition industry was built. They built it here in Canada because if Britain were taken over by Germany, the war industry would still be here. That was the thinking. And so to some degree, just like in the United States, the Second World War industrialized Canada. Of course, the industries were all wrong, right? I watched this interesting video on YouTube of a sort of an internal American military video warning about a problem at the end of the war. And I never thought about this till I saw this video. This was meant to be viewed by American leaders, and the same problem would exist in any country like Canada too, with a big war industry. And that is, when the day the war is declared over, all the contracts cease. and your factories are chock full of machinery, parts, half-built stuff. The buildings are chock full of stuff. It's in the way of using those factories for anything else. And this was a big problem that had to be dealt with quickly, because you're going to have millions of soldiers returning home, tens of thousands, hundreds of thousands. And what are they going to do right away? You know what they're going to do. They're going to cause endless social problems, because they're coming back shell-shocked, like my father came back from the war, shell-shocked, and they're going to drink, and they're going to get into trouble, and they need to get them into factories right away and put them to work. It was a serious post-war problem that had to be solved. They never thought about it. Everybody stop, put down your tools. Factories chock full. Half-built tanks that nobody wants. Stuff like that. You should never go to war. Okay, so I got one more to do. Do this guy right here. The leads on a lot of these components are steel, plated steel, so they're magnetic. Out comes this one, 0.006. Hey, it's an even number. I have a tray full of 0.006s somewhere. 8. Uh-oh. Another 7. 6. 0.006. Okay. Did I say I had some capacitors to test? I didn't test. I can't remember now. Got this guy. Let's test this guy. I mean, is there any doubt about the condition of these? Occasionally, yes. Occasionally I do a radio and these old capacitors actually check out really good. But only occasionally. 50 volts. Here we go. Look at that. Pop right open. Let's go up higher, 150. It's still popping open. Making sure the leads are connected. It's good for 600 volts. Let's give it the works here. 250. Wow, okay, so this capacitor is actually in good shape. So we'll try reading the value of it here. It should be 0.006. Just giving it a moment to discharge. Shove it over here. 0.006 would be very small to 0.5. 0.00. It'll be on this scale. Okay, now we just watch for the eye to pop open. Oh, here it is. It's not popping open very much. It's just popping open a little bit. And this would be 0.005, 0.006 is right here. So it's actually right on. Good show. Throw it in the garbage though. His tour of duty is over. And look at now. Okay, so I've lost track. Here it is. 0.006. That's going from here to here. At times like this, when I'm sticking my fingers in the radio, I glance at the power settings in my shop. Make sure I haven't left the make sure the radio isn't on. Especially a broken radio that's silent. It's real easy to forget that it's on. There. I should have used my clip leads to make sure I don't get the right, make sure I get the right post. Making a mistake at this point is really tough to find later. It's very tough to find your own mistakes. Just think of what we learned in school as kids, right? We learn that if you make a mistake, bad. I think a lot of unfortunate lessons get. I mean, maybe it's different now. Of course, I went to school a long time ago. The thing that bothered me the most, and this bothered me, was having to accept that you can't help your neighbor during a test. Poor kid struggling along, and he just needs a pointer. Sometimes I'm that kid, and I like somebody just, just give me a little hint here, and I can carry on with this test. But no, it's every man for himself. That's what you're taught in school. And the reason for that, it's to solve a problem teachers have. Teachers have a problem of grading students. So to solve that problem of grading students, because they have to, how well is he doing? How well is little Johnny doing? They have to adopt a teaching style and technique that involves testing. So, well, that's, of course you test, you gotta test kids, I mean, and I suppose you do too. But in my view, when a kid fails a class, it might be more reflective of the teacher. And I'm not suggesting for a minute that there aren't kids who are really tough to teach anything to. But who's in charge? Not the kid. Who's getting paid money? Not the kid. Where's my solder? Here it is. Over here. So after I do this, we will test the radio. There's a chance it's going to work. I think. Hey, what happened to my solder here? I guess there's always a chance it's going to work. It's a big terminal. Lots to heat up. Ooh. So this resistor is tack soldered here. It's not wrapped around the post. Oh, that just looks terrible. Get very much here. I was mentioning the leads are magnetic because see there's one stuck on my cutter. Next thing you know it's going to be in the radio. And it won't help. Okay, let's see if we can get this a little better. Lots of air in there. Right. That might look a little bit better. Let's try that. Too much air in the joint. Maybe I said that in my college days. When I started at my professional or my career type job at Toronto Hydro, there were lots of new terms I wasn't familiar with. One of them was pothead, P-O-T-H-E-A-D, pothead. So I saw this term quite a few times, pothead, and then in a meeting, I very innocently said pothead, and everyone looked at me, and then somebody said pothead, and I was taken aback because I thought he was referring to me. and I was just stunned, and he goes, no, pothead, it's a cable termination, pothead. Funny things that happen, eh? Hey, we're ready to try this guy out now. Everybody's hooked up, staying on. Try him out. Let's hurry up. Hurry up and try him out. Yes. Okay. Power on. Dim bulbs working normal. If they weren't, you would have seen me jump. Okay, volume down. Okay, my little radio, what can you do now? Running with 98 big volts. I'm going to give it the full voltage here. Just in case. So it should be warmed up by now. Oh, something coming. Okay, finger test on the volume control. Here. Not a sound. Yeah, another piece of wire in there. Not a sound. There's it. And that's it for today. Hopefully this radio is getting closer to working and not getting farther from working as I go. But that's all I'm going to do today on it. And keep my fingers crossed. It's going to start making sound soon. Thanks a lot for watching, and see you on the next video. Actually, you'll see me. Actually, you don't even see me, just my hand.